Hi there, recently Mike Ince contacted me and said he'd learnt quite a lot from my Jerry Howell Farm Boy series, and he's actually managed to complete his own Farm Boy, so I'll show you a brief video clip of that. And in this video I'm going to start on the most complicated component of the Jerry Howell V-twin, and that is the valve gear case. So I've already squared up this piece of aluminium and done a bit of marking up, and I think what I'm going to do first of all is create this boss on here on the lathe. Okay, so I've centred the piece, and it is actually off centre because these two edges here are close to the centre than these two edges here. But I've used this tool just to touch the sides, just to make sure that I'm pretty much there, and I think I am. But I do have a problem in the fact that when I tighten up the jaws of the chuck, it pulls one of the edges slightly out by about 1/10 thou, and that's sort of telling me that the front and rear faces aren't exactly sort of perpendicular with the sides. So I need to create a boss on here that's 375 thou sort of deep, but I'll make it 385 thou. Once I've done that, I'll take sort of 10 thou off the remainder, so that should sort of like square it up hopefully in relation to the sides. Okay, so I've set the carriage stop to about 0.4 really, I think, of an inch, and I'll cut in just short of this scribe line here. Okay, I think I might change my approach here. Rather than cutting inwards, I think I might just start nibbling away here by doing that. Get rid of these interrupted cuts. Give it a try. So there's just 1/8 thou to take off this now to get it down to 2.123 of an inch. So I'm just going to move the compound sliding by a few thou, and then I'll withdraw the tool. Pretty good. Okay, so what I'll do now is I'll just measure the distance between this face and that face, and then I'll face this end off here to get it down to 0.375 of an inch, but I'll do that off camera. So now there's a requirement to cut a groove for an oil way, and I've had to sort of extend the tool out of the holder, otherwise I'd hit this, but I've got to go to a depth of 80 thou. Oh, I have hit it. Okay, so a slight change of plan. There's a requirement to cut a radius on here, and to a depth of 100 thou. So I'm going to use this round tool here. Now the diameter of this radius is going to be 2.7 of an inch, but I know that the diameter of this boss here is 2.123, so if I take 2.123 off 2.7, I get 0.577. Divide that by 2, I get 288 thou and a half. So if I withdraw this by that amount, 1, 2, 5, 6, 8. Seems to be working okay, so I'll continue with this method and then I'll get back to you. Okay, so now I should be able to get in and cut this oil way, which is 80 thou deep. And now there's a requirement to cut a groove for an O-ring, and this needs to be 140 thou from this front face and 63 thou deep and 70 thou wide, but I'll do that off camera. So now there's a requirement to drill and ream this to 7/16 of an inch. I've already opened it up with a small drill, and this is a 27/64 drill bit. And now there's a requirement to open this up to a bore of 0.827 of an inch to take a 21mm ball bearing, and it needs to go to a depth of 0.196. So I've set my carriage stop to 0.916, and we'll give it a try. So it's 8245 and we're looking for 827, so we're pretty close. Well, that's just a tad on the big side. I'm a bit disappointed with that. I think I can Loctite it in place, so it should be alright. And now there's a requirement to take 9 thou off the far face for a diameter of 0.7 of an inch. That's just to create a bit of clearance for the ball bearing. So now I need to remove all that material there. Now I've tried to put it in the 4-jaw chuck on the lathe, but I just can't get it sort of centered right. So I think what I'm going to do is I'm going to go over to the mill and remove that. Well, I think this is going to take a while. So I've just switched it around in this 3-jaw chuck, offered some support, and I need to take 100th thou off here, and then I'll finish it off with that little radius tool. Seems to be working out okay. So I've come up short by about 100th thou, and the diameter of this needs to be 2.7. So if I divide 2.7 by 2, I get 1.35. Now I've put a round tool on here, and that's pushed up against this bar here, which is 7/16, which is 0.4375. If I divide 0.4375 by 2, I get around about 0.219. If I take 0.219 off half this diameter, which is 1.35, I get 1.131. So I need to move it back by that amount. 2, 3, 4, 5, 6, 7, 8, 9. That's 1. 1, 2, 3, 1. So that should put, oops, spot on where I need to cut this little radius. So I'll just take it in gradually, but it's a little bit tight around here at the moment, so I'll do this bit off camera. So there's a requirement to leave 1.24 of an inch on this sort of upright here, and also here. So I think what I'm going to do is I'm going to turn these corners off until I get sort of close to those points, and then I'll probably have to finish it off on the rotary table or something like that. That's pretty much spot on. Happy with that. Well, that seems to have worked out okay, and I've decided to leave this. I'm not going to turn this off because that area needs to be turned down and this area needs to be turned down. But for the moment I'm going to leave it because I've got a flat there, I've got a flat here, flat there, flat there, and that will help me hold it in the vise on the mill. Okay, so I've made sure that the vise is perpendicular to the table using this square, and using the coaxial indicator I've made sure it's centered. So the DRO is set to 0 at the moment, and I'm going to use the bolt circle function to drill 4 holes, one at the top, one at the right hand side, one at the bottom and one at the left hand side. Okay, so for the bolt circle function, the diameter of the circle is 2.430. Starting angle 0, which is the right hand side of the piece here. Ending 360. Number of holes 5, because I always sort of like end on the start hole, if that makes sense. And that's giving me the first position. So I'll keep on going round with the centre drill, and then I'll drill with a 9/64 of an inch diameter drill bit, but I'll do that off camera. Now for some arithmetic. There's a requirement to drill and tap a couple of holes here. Should be quarter be 20. I'm going to go for 6mm. And the problem is the dimensions of this are based on this centre line, which runs at 45 degrees, so it's dead between these 2 points here, which you've got flats on. So I need to work out, what I don't want to do is to start swivelling this round and work to these dimensions here, because basically these holes are offset by 0.125 of an inch along this centre line and by 0.7 of an inch from this centre line. What I need to do is to work out the x and y coordinates to enable me to leave the piece as it is currently in the vise. Okay, so this is a slightly expanded diagram of the previous one, so we need to determine x and y. So first of all, we need to determine this value here, a. So if we take tan 45 is equal to a over 0.125. Now tan 45 is 1 anyway, so it's 1 multiplied by 1.125, so a is equal to 0.125. And that makes sense because this is an equilateral triangle, so that's 90 degrees, that's 45 degrees, so these two dimensions are exactly the same. So having determined that as being 0.125, we can work out that this distance here between there and there is equal to 0.7 minus 0.125, so that comes in at 0.575 of an inch. So having determined that value there, we can then work out y. So if we take sine 45 is equal to y over 0.575, and that comes in at 0.4066. So we've got y now. Now, if we try and determine the value of C, we can take the square of 0.125 plus the square of 0.125, and the square root of that value comes in at 0.177 of an inch. So what we can do now is to try and work out what D is. So cosine 45 is equal to D over 0.575, and D comes in at 0.4066. So if we add D and C together, we get X equal 0.5836. So I can go over to the mill now and leave the piece as it is in the vise and drill and tap that coordinate there. I think X will be a minus value and Y will be a positive value, and then I can repeat the exact same process on this side. So X will be a positive value and Y will be a negative value. And now to drill and tap the other one. But I'll do that off camera. Oh dear, I've messed up a little bit here because I've just realised that with it being a mirror image, the Y coordinate needs to be minus 0.5836 and the X coordinate needs to be plus 4066, and unfortunately I've already drilled a hole. So what I'll have to do at some point is plug that. Hopefully it won't interfere with anything. So I'll readjust the table to those coordinates and I'll drill and tap, but I'll do all that off camera. Well, I could kick myself for not getting that hole in the right place. I have plugged it with some aluminium and used some Loctite 638, so it'll be pretty permanent, I think. There will be a bit of interference because these holes need to be opened up to 3/8 of an inch at some later date. But I think it'll be alright, and it fits something like that. And in my next video I'll drill some holes in these areas for the tappet bushes or bushings, and all this area will be recessed to different levels, but it's coming along. Well, I knew this part would be quite difficult to make, and obviously I've made a couple of errors so far, hopefully both recoverable. The hole for the bearing, I mean, it's just about 1 thou too wide. But I think I can get away with that with some Loctite 638, and I can't believe I didn't get that hole in the right place, but anyway, it is what it is. But apart from that, I think it's looking okay. I'm not following exactly the instructions as detailed in the drawings, but I'm not too far off, I don't think. But anyway, I hope you like the results so far, and I hope to see you later.